Historiography of science is the history of the treatment of science as a subject of historical investigation. Historiography, in the narrow sense of the term, means the history of historical writing. More broadly conceived, it also embraces historical methodology, including the values and principles guiding the selection of subjects, topics, the construction of categories of historical analysis, and the demarcation of historical periodization. So we're seeing historiography as that which speaks concerning the history of historical writing. More broadly, it embraces historical method. It also embraces things such as categories of historical analyzation and demarcation of historical periodization. Although historical scholarship was regarded with skepticism in the 17th century, the debate between the ancients and the moderns introduces into historical thinking the narrative of progress, punctuated by inventions such as the compass, gunpowder, and the printing press, thus linking science and technology to the advancement of human civilization. Comprehensive historical narratives that integrated science and technology into the story of civilization were rare. The magisterial Encyclopedia of Denis Diderot and Jean d'Alembert, 17 volumes of text and 11 of plates from 1751 to 1772, identified the sciences, arts, and trades as essential components of a grand story of enlightenment and progress. Of course, this preliminary discourse to the Encyclopedia of Diderot in 1751 laid out the first narrative of the scientific revolution from Galileo to Newton and Locke, depicted as the story of heroic efforts against the dark and repressive forces of ignorance, as in Galileo's struggles with the Inquisition. Published in the same year, Voltaire's History of Louis XIV was one of the few Enlightenment works to incorporate the natural sciences, albeit cursorily, into modern history. And despite criticisms of the Enlightenment's positive view of science, most notably by Jean-Jacques Rousseau, the approach and tone of this narrative, again, it would be the preliminary discourse to the Encyclopedia of Diderot. It shaped subsequent historical studies of science as stories viewed from within. Enlightenment and again 18th century textbooks and encyclopedias about the natural world both organized extant natural knowledge and created simple chronologies that seeked to map the temporal unfolding of science's principal ideas and methods of investigation. Montoucla's History of Mathematics in 2 volumes, written in 1758, was an early example of a type of history of the sciences that flourished at the end of the 18th century and was particularly popular in the German states following in the 19th. Perhaps the most ambitious and extensive example of this genre was the history of the arts and the sciences since their renewal around the year 1200. Written by leading scholars and published in Göttingen from 1796 onward. Remember, Göttingen, the scholars are very important for the writing and the eventual invention of many different modern scientific disciplines. This series included histories of mathematics in 4 volumes by Abraham Gotthelf Kastner, 1796 to 1800, physics in 9 volumes, one by Friedrich Wilhelm August Murhard, 1798 to 1799, and 8 volumes by Johann Carl Fischer from 1801 to 1808. Chemistry in 3 volumes by Johann Friedrich Gmelin from 1797 to 1799, and Technology in 2 volumes on the technologies of war by Johann Gottfried Heuer, 1797 to 1800, and 3 volumes on other technologies by Johann Heydrich Mortiz Pope, 1807 to 1811. The collective effort of these authors, all practitioners in the sciences and technology, resulted in positivist chronologies suited as rational overviews of their fields. Kastner limited the history of a science to how the theories were discovered, became known, and later corrected, expanded, and applied. These histories furthermore separated science and its practitioners from the public. As Kastner explained, no one could read them who could not also write them. The positivist and rationalist history of science guided the production and selection of personas and topics for the chronologies, biographies, bibliographies, and translations and editions of scientific works that appeared in the 19th century, especially at its close. As in the 18th century, these histories of the 19th were written less in service of history than of science. They contributed to the intellectual definition, constitution, and boundary of disciplines. Guided by chronology rather than narrative, these histories took the study of nature out of its historical context and ordered results, investigations, and families of problems according to their relative success in maintaining a position in the corpus of scientific knowledge. Value judgments condemning certain traditions like Naturphilosophie to the historical trash can were therefore inevitable. Written not by trained historians but by scientists, philosophers, and others whose avocation was history, these histories fell outside the range of even history's historiography and methodology. Rarely did they employ historical categories of analysis more complex than the views of nature used by John Theodor Merz in A History of European Thought in the 19th Century in 4 volumes written from 1903 to 1914 to parse scientific discoveries into like-minded groups. Histories of the sciences written not only in service of science but of the nation appeared in greater numbers after the unifications of Italia from 1866 to 1870, and that of Germany in the year 1871. Again, under the auspices of national agencies, the French published the works of Lavoisier, 6 volumes from 1864 to 1893, the Dutch of Christian Huygens, 22 volumes from 1888 to 1950, the Italians of Galileo Galilei, 19 volumes from 1890 to 1909, and the Swiss of Leonhard Euler, 32 volumes from 1911 to 1998. These collections exhibited every bit of the nationalistic sentiment found in other cultural productions of the period, like national operas, museums, theaters, and monuments that aided the construction of national identity. Here, the motivation for elaborately documenting the history of great scientists dovetailed with that behind the grand state-supported historical projects, for example, the Monumenta Germaniae Historica from 1819 to present, that collects the past in search of an identity for the present. Criticisms of this type of history were and still are vocal. Near the century's close, Friedrich Nietzsche condemned the deadening fetish for excess history, indisguisable knowledge, and bibliographical information. At the end of the 20th century, Georges Canguilhem noted that this kind of history, based on sources, discoveries, influences, priorities, and successions, was a victim of the classificatory scheme that made it possible, the disciplines, and so was doomed to failure. Nonetheless, these collections and similar ones that followed provided a firm foundation for what later became known as internal history of science, the genre dominant at the field's inauguration early in the 20th century, and upon which professional growth in the history of science rested after the Second World War. 19th century historical narratives of science organized science's past around biographies, ideas, theories, and investigative techniques. At the same time, institutional histories also became prominent, the result of the phenomenal growth of institutions dedicated to scientific practice and education across the century. These in-house histories, although often uncritically laudatory, partially exposed for historical examination the social and the material network of support necessary for scientific practice. For Germany, where the production of historical scholarship was often a state-supported enterprise, these histories ranged from Friedrich Paulsen's Comprehensive History of the German University System in 3 volumes from 1896 to 1897. An English translation occurred also in 1906. And then also Carl Gustav Adolf von Harnack's History of the Prussian Academy of Sciences in 3 volumes, published in 1900, to Max Lentz's History of the Friedrich Wilhelm University in Berlin in 4 volumes from 1910 to 1918, or articles by scientists on their institutes. For example, Eduard Rieke, Voldemar Voigt, and Franz Kopp on Göttingen's Physical Institute, published in a scientific journal, Physikalische Zeitschrift, in 1905. Also in the 19th century, philosophers, some of them practicing scientists, analyzed branches of scientific knowledge from an epistemological perspective. Wilhelm Wewel's History of the Inductive Sciences in 1837 introduced a method for rationally reconstructing a scientific discovery, which Wewel illustrated through his analysis of Sir Isaac Newton's work on gravity. Ernst Mach's equally imaginative treatise in 1883, titled The Development of Mechanics, also influenced the likes of Albert Einstein. By 1900, the historical study of science included categories of analysis drawn largely from the sciences or philosophy. Most analysts and most analysts applied them to the evolution of ideas or techniques within one discipline or a set of closely related disciplines, rather than integrating science and its activities into broader historical movements. For example, Albert Longs's influential History of Materialism in 1866 grew out of his interest in the history of workers' movements. Nonetheless, he separated the history of science from social concerns. These disciplinary histories escaped the types of criticism that historians had by then developed to assure the production of objective and innovative historical knowledge, as in Karl Lamprecht's path-breaking and comprehensive cultural history. Again, Karl Lamprecht, really important figure within the historiography of science, but also mostly just history in general, with only a few exceptions, such as the sociologist Max Weber's narrative on the negative effects of rationalization in a work that he published in 1905 titled The Protestant Ethic and the Spirit of Capitalism, and the mathematician Wilhelm Arendt's objection to the omission of politics in Leo Königsberger's biography of 1904 of the mathematician Carl Gustav Jacobi. No attempt was made in the long 19th century, not even by a historian as innovative as Lamprecht, to link the history of science to broader historical trends. On the eve of the Great War, World War I as we know today, the typical history of science resembled Emmanuel Radl's History of Biological Theories, published in 1913, which covered a single scientific discipline in terms of its major practitioners, its ideas, theories, and methods. He wrote from a philosophical perspective whose goal was to understand scientific ideas, individual genius, or more generally, the progress of the human mind. And so maybe today we would probably classify that as a philosophy of science, rather as an actual historiography of science. Next, we'll talk about the rise of the social sciences and the reform of historical scholarship after the Great War.